So when it comes to test analytics, we rely on test analytics to decide if we are safe to release the feature or not. But when analytics isn't tied to decision, it is just reporting, and reporting does not reduce the risk. So the pipeline is green, the deployment is also fine, and still user may be reporting bug because of same. Just a minute. So in the trend testing process, the pipeline is the new dashboard. And if we are not utilizing the pipeline in a correct way, then it might be possible that the pipeline data is kind of lying to us. So pass rate is good, coverage is also high, build time is fast, and there is zero P1 or any critical bug, and the trend is improving. But when we zoom in little, we will realize that some of the tests are flaky, and we quietly skip them because of lack of time, and we don't deep dive into RCA for those flakiness. We then inti- uh, skip some of the critical flows or edge cases, or we also delete the integration test from the previous sprint to meet the build SLA. And also there are cases like high priority works have been closed by the PM or QA manager, and been marked as a feature or been moved to next sprint, and the trend improves because the scope keeps sinking. Now when I say trend is basically measure of any metric over the period of time, and the metrics that cannot be questioned are not metrics, they are just comfort for testers. Now coming to the three signals that may feel like safety but they aren't. So first is the pass rate. In our pipeline we can have 98% of pass rate, and still we can miss a very critical word. The reason is that pass rate denotes the number of test cases passed, and pass rate is basically pass rate basically reflects the execution. It does not reflect the risk coverage. Then comes the code coverage percent. So code coverage percent again is the number of lines covered during the test run. We can have 90% of code coverage percent, but still many of the things can be skipped because code coverage percent does not reflect the decision coverage or the decisions that have been validated. The last is the bud count trend. So when it comes to bud count, as the bud count decreases, the team feels satisfaction in the quality of the product. But bud trend can decline because of reporting behavior also, not just because of the product being improved. So these are the three signals, and these are not the edge cases, these are just default state of some test analytics that we use in our day-to-day testing process. Now what is the root cause behind them? So the root cause is just a minute. Root cause is that we designed our matrix to answer how we are doing, not what should we do next. And reporting answers the first question, that how are we doing, while analytics answer the second question, that what should we do next. And most of the team built reporting and they called it analytics. And this pattern is not new. This was even reported by Canner and Bond in their IEEE 2004 paper. So we can see that in the last 20 years, this pattern hasn't changed, and it is still familiar in our day-to-day testing process. Okay. Now when it comes to uh, test analytics, so how should I design the test analytics? So the first thing that I would focus on is the decision. What needs to be made? Example is like, are we safe to ship this release? The second factor is uncertainty, because decision drives the uncertainty. What do we not know? Example is like, are the critical journey actually working or just the test suit? And the third is the signal. How much percent of the top user flow or critical flow is being parsed? Now, what I replaced and with what thing I replaced them. Okay. So as we can see in the table, I've replaced overall pass percentage rate, because it inflates the flaky test. It The scope reduction is been reduced. Sorry, it inflates the scope reduction. I replaced with it with wrist path coverage percent. Now the second factor that I replaced is the severity level plus bud count. So why I replaced the severity level and bud count? Because severity is kind of assigned opinion, and bud count ignore how many users are actually affected. So instead of severe using the severity level plus bud count, I started using the feature touch frequency plus similar step history, like how frequently the feature was being tested, or is there any bud been stepped in the history, similar bud stepped in the history. Okay. The third factor that I have replaced is the build pass fail status, because build pass fail status is kind of binary signal which hides the flatness, it's in the scope and strip the growth. And I replace them with flat flatness rate trend plus test deleted this spin count, like how much flatness is being increased in this current sprint, or how much we have deleted the test from last sprint. And then the most important is the automation coverage percent. Automation coverage percent does not give any significant result, and as it just count the scripts and it does not help in making any relevant decisions, and it is easy to inflate. Now instead of automation coverage percent, I started focusing on defect prod by the automation before the prod, like on pre-prod or UAT kind of environment before every sprint, as it helps in realizing many kinds of behavior, like what are the features in which the build is been failing before sanity or during sanity, those kinds of data. And all this replacement does not require any new tool or any new knowledge. They just require different kinds of questions. So this is just a stress test. Just focus on these four questions and find the answer by yourself, and you may realize that your test you are doing either test reporting or test analytics. So what decision does it change? If you can name it in one sentence, then it's okay. And if you are hesitating, then obviously the answer is awareness. It is just reporting. What does the metric assume? You can state the assumption, because if the team is aware about the assumption that has been considered while the maintaining the pipeline, then it can help in better test analytics. And if you can't mention the assumption, then again the metric is just black box. How the team fate this looking good? So maybe every time the data is not as per our expectation, so how can we modify them to look good in the report? That's also matter. Would you still track this if nobody saw it? That's an important question. That if you are just individual QA in the group, will you still do the same kinds of test analytics? Try this for the dashboard that you are currently using, and you may get many answers that could improve your trend pipeline. First, pick your team's most used metrics, Write down what decision it changes. If you hesitate, then again it's reporting. Second, before the next release review, count the number of strip test and flakiness and deleted test. Those can give the better data than any other metric. Third, if for every metric that you own, ask how would you improve the number without improving the product, because every metric teaches your team how to optimize for. And again, if the metric does not change a decision, it is reporting. So that's it. Just try to build analytics that change the decision, not dashboard that perform confidence. Okay. In case anyone has any question, please connect on Slack or connect with me on LinkedIn. Thank you.